Hello guys, welcome back to Infinite Insight Geometry, lesson 1.10, Proof Strategies. Alright, let's begin. When proving something, you may get stuck, because proofs are one of the hardest skills in geometry to master. You need a lot of strategies that will help you solve proofs faster and more accurately, so make sure you don't get stuck or get the wrong answer. So, I have 8 strategies that I'm going to show you, and the first one is work forwards. This is pretty simple. I'm pretty sure you guys are already doing this because this is the main way to solve proofs. Remember that any proof can be solved just by using the given statements and definitions and theorems. What can you conclude from the given statements? You don't need anything else. You might have to work forward. But sometimes you could get stuck, and sometimes you hit a roadblock where you cannot solve anymore. Work backwards. You have 2 ends and you're trying to connect them together. You can work in one way, but when you get stuck, you can work the other way and connect them in the middle. Look at your conclusion. What patterns or deductions can you make? What do you need to make the conclusion true? Look for definitions. An angle that is 90 degrees is a right angle, and any right angle is 90 degrees. This biconditional definition, the premise of definitions is that they're biconditional. This is that, and that is this. They equal each other, so we can substitute one for the other very easily. Obtain additional information. Diagrams. Now, a while back in lesson 1.8 in 2-column proofs, I said that diagrams can be misleading, but when used correctly, they can be key parts to knowing what to gain from the diagram, and they can also help you solve proofs. For example, when any 2 lines intersect, they form angles. And using these angles can help solve the angles of a triangle, or the sides of a triangle, or so on. Using these additional pieces of information that come from diagrams are key to solving any proof. Look for theorems. That's number 5. Applying useful theorems can save lots of time while proving. Of course, any given proof can just be solved using given statements, definitions, and postulates. But remember that theorems are more of a shortcut. Theorems are something that you have already proven and you can use again, like gained information to solve new proofs. When using a theorem about proving something congruent, theorems make everything easier. Make the problem smaller. Solving a very difficult proof is much harder than solving many smaller ones because you're more likely to get stuck. Smaller proofs are easier because you can solve them easily. Even though there's a lot of them, they're still going to take less time than the difficult proof because you can get stuck on the difficult proof. Break the theorem into multiple parts. For example, later on in the course, you will see congruence of triangles, side-side congruence. In this type of congruence, you have 2 triangles and they have 3 sides. And if those 3 sides are equal to the other triangle's 3 sides, then they are congruent. So the problem comes from solving 2 triangles congruent, which is a very difficult proof, to just trying to make all of the sides congruent, which is much easier. Look for congruency. Now, I've been saying this word congruence. What does it mean? It means being equal in length, size, or shape, or length, size, and shape. 2 congruent triangles have the same shape and the same size. They have the same area and the same perimeter. They are equal in every way. The only difference is that they are in different places. proving triangles congruent also means proving lots of angles and sides congruent as well, because any two triangles will have the same sides and angles. And the last one, number 8, use algebra. Algebra is another part of math. And all math comes together to make one beautiful whole. Algebra and geometry are just two parts of the same topic. So you use algebra to prove geometric equations, like, for example, saying that this line is equal to that line, or this triangle is equal to that triangle, or trying to prove stuff about the areas of each one. Using algebra can help you. So here's the two-column proof that we were given before. Now, this proof, we can work from forwards to backward, or backwards. Here we can see we can go 1, 2, 3, but we can also go backwards, 7, 6, 5. The only problem with two-column proofs is that you also have to give a number to each statement and reason. And you don't know what numbers are there. You don't know how many reasons or statements that you're going to need. So make sure that you get all of the needed information, you work forwards and you work backwards, and you know how to solve the proof before writing your two-column proof. Also, look for definitions. BCD equals 90. That's the definition of a right angle. You also have the definition of congruency. You just plug that in. You also have the definition of complementary angles. All of these are useful tools to solve proofs. And these proofs, these two-column proofs, these flow proofs, these paragraph proofs, and all of these proof strategies will be very, very helpful when solving proofs in much harder units. And that will be all for today's lesson. If you like the video, please like and subscribe and comment. If you have any questions, please email me. My Gmail is down below in the description, and I will see you next time.